Hello everyone. Let us start the discussion of the next part, that is working of MOSFET. Okay, that is depletion type MOSFET. This part I am referring to as 1.2. Okay, so uh, how you may get a question in the exam that explain the working of n channel depletion type MOSFET, then you should write the following answer. Now, not to explain its working, we have to apply the biasing voltage for the MOSFET. Okay? Biasing means we have to give the voltage across gate and source, and you have to give voltage across drain and source. Okay, initially what we do is we make gate to source voltage over here, that is VGS, we are making it as 0, and VDS is we are giving some positive voltage. That is what he is saying. Okay, now what happens when we do so? Just see over here, you are observing again we are taken the depletion type MOSFET. This is gate terminal, this is source, and this is drain. Between gate as well as source, we are connecting one source, that is called as VGS. Between this drain and the source, we are connecting one more voltage source that may be called as VDD, and here we are referring to it as VDS. Now initially what we will do is we will give VGS 0 volt, we will make it 0, and VDS we give some positive voltage. Now what happens when we give VDS some positive voltage? That is, what happens is, see, this is the negative term of the battery. It acts as a source of electrons, meaning it is producing electrons and it will be sending to the source over here. It is being connected to the source terminal over here, and in the source terminal we have a n type material, and this n type in this n type material, n-type material, there will be majority charge carriers will be the electrons. Now here in the majority charge carriers electrons, and from negative terminal electrons are coming in. So what happens is whatever electrons are there over here, they'll be uh, they'll be pushed towards that, they'll be repelled towards the channel. They'll be, the electrons in the source will be repelled by the electrons that are emitting from the negative terminal of the battery. They'll be forced to move to the channel. This is one part. Next part is, this is positive terminal of the battery, and positive terminal of the battery will be attracting electrons always. So it is being connected to this drain, and the drain also there will be the majority charge carriers will be electrons, and it is again connected to channel. So here in the source side there will be force of repulsion for the electrons. In the drain side there will be force of attraction for the electrons. Hence the electrons will move from source towards drain, passing through the channel. Okay, and the electrons will be flowing in the clockwise direction like this. And just see over here, dotted line we are showing, it is to indicate the drain current ID. You just observe over here, the current is conventional flow of current, and it is shown in the opposite direction to that of flow of electron. This is the first case in which we made VGS 0 and VDD we are giving it as some positive voltage. Okay, now the second case we will take, in which what we do is we make VGS negative. Let us say for example we will give -1 volt, and VDS or VDD we give it as some positive voltage only. What happens when we give VGS negative voltage? See, here we are giving positive voltage over here across the drain and source. Again there will be force of attraction for the electron, there will be force of repulsion for the electrons, hence the electrons will be moving. There is no doubt in that. What is the difference when we give VGS negative voltage? What happens is, this negative of the battery, again it will be producing electrons, it will be coming over here, and these electrons in the gate will be exerting repulsive force on the electron that are moving in the channel. Now what happens when there is a repulsive force that is coming from this gate means, some of the electrons will jump to this substrate, and this substrate is made up of p-type material, in which the majority charge carriers will be the holes. Now what happens is, these holes that are jumping into the substrate will recombine with the holes over there, and they become immobile. What is the meaning of this is the number of electrons that are moving through the channel and reaching the drain will be less in this case, because some of the electrons are already being recombined in the P channel. So when the less number of electrons are moving from source towards drain, then obviously in the current will be less. Now what we'll do in the next case, we make VGS minus 2 volt. Earlier we have taken example of minus 1 volt. Now we take minus 2 volt. Then what happens is, more number of electrons are emitted by this negative terminal, more repulsive force will be there, and further more number of electrons will be jumping into substrate, and total electron that are flowing through the channel is further reduced, and because of that current will be further reduced. So what is the inference that we can draw is, as we make VGS negative, more and more negative, more and more electrons will recombine with the substrate holes and less current will be flowing. Okay, this is next part. Let us go to the third part. If you make VGS positive, whatever you are saying over here, negative terminal is connected to gate, positive is connected to source. If you reverse the battery terminals, then what happens is, this VGS positive of the battery will be coming over here. It will be attracting. What will do is, it will attract electrons. These electrons will be tried to pull towards it, but they will not be coming to gate. Why? It is because of this layer, that is silicon dioxide layer. This silicon dioxide layer will not allow electrons that are flowing into the channel to reach the gate. Instead, if you further increase the VGS in positive direction, whatever p-type substrate we have in that, majority charge carriers are holes only, but there will be few minority electrons also. Now those minority free electron, minority charge carriers will be attracted by this gate, okay, because of positive potential that we are applying over here. Now they will jump into this channel, and now because of this insulation layer, it cannot reach gate, and across this drain and source we already connected positive potential. Because of this positive potential, whatever electron that are jumping into channel will be made to move in the clockwise direction, that is they are adding to the existing electrons, meaning is more number of electrons are flowing. More number of electrons are flowing compared to the first case means more current is flowing. So this is how the working of n channel depletion type MOSFET is. Okay, now let us go to its characteristics. As already explained you in detail, there is nothing much to explain. We are just drawing its working. Okay, what we do is, we initially are saying that we make VGS equal to 0 and we are varying the VDS. As I increase VDS slowly, the current gradually increases. At one point of time it will become constant and it will remain constant throughout, and this maximum current that is flowing is called as IDSS, as we called it in case of JFET. Now we made VGS minus 1 volt. So when we make VGS minus 1 volt, what happens is, some of the electrons in the channel will be repelled towards the substrate and they will recombine. The meaning is, less number of electrons will be flowing through the channel, so hence less current is flowing. So you can see over here, VDS is again made 0 as we are increasing VDS slowly. Again the current will increase gradually, and at one point of time it will become saturation. Just observe saturation point of VGS equal to 0 and VGS equal to minus 1. There is a huge difference of this saturation. The meaning is, here maximum current was more because of no repulsive force was there from the gate on the electron that are moving in the channel. Over here in this case, there will be force of repulsion because of negative voltage being applied to gate to source. That is why less current is flowing. As you increase VGS further, again this maximum current will be decreasing. At say, let us say minus 6 volt, it is reaching its pinch of voltage. This is one case. Next case is, lastly I explained the working. If you make VGS equal to plus 1 volt, so what happens in that case is, more number of electrons are attracted towards the gate, and they cannot reach the gate because of insulation layer. Instead they take part in conduction that is going on in the channel, hence more number of electrons are available for current carrying. So compared to the previous case, that is V is equal to 0, now more number of electrons are available for current conduction, hence more current will be flowing. That is what being shown over here. Okay, so we have drawn a curve over here. To the left side is this curve, we call it as ohmic region. The meaning is it is obeying the Ohm's law, V is equal to I into R, and to the right side of this curve we call it as saturation region, because here the current is remaining constant. So this is what is called as drain characteristics. Right? You can just go through the slides. Fine. Okay. Now lastly we'll go for transfer characteristics. Now drain characteristics was drawn with VDS with respect to ID. Now in this transfer characteristics we are taking, or we are drawing the characteristics by taking VGS on x-axis and ID on the y-axis. Okay, so when VGS was 0, we observed maximum current as IDSS. You will be remembering, right? So IDSS was the maximum current. As we increased the VGS to -1, then less current was flowing. It is something over here. And when we made VGS equal to -2, again less current, -3, less current, -4, -5, and around -6 volt it was pinch off, no current was flowing. So all those points we are joining them together. This is one case. In the next case, when we made VGS +1, so when we made VGS positive, more number of electrons were there for current carrying, and hence more current was flowing. That is shown over here. So if you join them all those things together, then it is called as the transfer characteristics. So this ID axis, to the left side we have depletion mode, to the right side we have enhancement mode. Okay, then the current that is flowing is called as drain current. It is given by the expression that is called a square law relation. ID is equal to IDSS multiplied by 1 minus VGS divided by VGS of whole square. Now what is that VGS of? Is VGS of is nothing but this pinch of voltage VP. Okay, this is all about the transfer and drain characteristics of N channel MOSFET. Quickly we will recap the P channel also. Okay, so just observe here what is the difference you are observing. There we had P channel substrate and we had N channel, and over in this case we have N channel substrate, we have P channel, and source and drain also is having P type material. Okay, now there we have given VGS negative, here we are giving VGS positive. Okay, and when VGS is made negative, more current is flowing. Similarly the case with the transfer characteristics as well. Okay, and lastly the symbols. Okay, just see here conventional symbols that we are drawing is for the N channel MOSFET, arrow is going in, for the P channel arrow is going out. In majority of the cases this substrate is being shorted to the source. Okay, that is not shown over here, but you can find in the textbooks as this line is connected to source. Thank you.